here at the bottom are just the red blood cells themselves. They're the most dense, so they all sink to the bottom. And you can see this is really dark. That's because, again, all the red blood cells have been separated from the rest of the blood. And then this larger portion, this sort of yellowish clear fluid, that's the plasma, the liquid part of the blood. So normally, these red blood cells are mixed with the plasma so it can flow, but in this case, they're separated. Now these samples show, if you look at them, can you see the difference between them?
Yeah, they're blurry.
Yeah, and so what these are actually indicating are the results of a cholesterol test.
Oh.
So this represents blood that's a normal range of cholesterol, which is less than, about 150 milligrams per deciliter. This is one that's sort of borderline high cholesterol, and it looks pretty close. But then once you start to look at high cholesterol, okay, that's the one.
It's all like blurry.
Yeah, it's thicker. It's because cholesterol is basically like a type of fat. And so this is really high cholesterol. So you can see it gets cloudier as it goes along. And today we're going to be talking about what cholesterol is and why it's something. Some types of cholesterol are bad for you. Yeah, Maggie?
Where'd you get the blood? Yeah.
It's actually not real blood. It's simulated blood.
I was gonna say.
What's that?
Bobby, it's just made to look like blood.
You know, like told me like the Cheerios.
Yeah.
Like, if we eat it, like chew it, and like it's on that. That's on a circle. So
No. But no,
You
like
lied?
I was joking.
Oh, that's
Joking and lying, two different things. It's a fine line. Though.
Sure.
But no, like Cheerios on the box says lowers cholesterol.
It does.
Whole grains, like Cheerios are made with whole grain or other breads and things like that. Whole grain is good for lowering cholesterol, oatmeal, things like that. What I said earlier is that Cheerios are good for your cholesterol because of their shape. They go through your blood vessels and they scrape out the plaque, but the hole in the middle allows the blood still to go through
But
it.
there's not
I
all.
believe them too.
And Cheerios?
Yeah. Wait, but we learned about. I don't know what they're doing. There's not
I was joking, Jared. I wasn't being
Jared.
truthful. All right. So let's go on and talk today about blood vessels. And we already sort of started talking about this when we were talking about the heart and the parts of the heart. But we're going to talk some more specifics here. So we know that there are arteries and veins. We haven't yet talked about the capillaries. So, but these are the three main types of blood vessels. Arteries, capillaries, and veins. And so if you were to take out all of the blood vessels from a person's body, they'd be 60,000 miles long.
Wow, guys.
So we have an enormous amount of, most of that is capillaries, the vast majority. But we have a huge, huge amount of blood vessels that run throughout our body. Basically, every cell in your body is surrounded by this very, very thin layer of capillaries.
How do they like get that measurement of 60?
They just estimate it based on, if you look at a small sample and see how much there is, then they can expand that just mathematically to see what a full human would be. All right, so arteries carry blood. What did we say about the direction?
Oh, I know. I remember. Arteries carry away.
Yes, they carry blood away from the heart. And you can remember because the A in arteries goes away. And the arteries are, almost all of them carry oxygenated blood. Because they're going away from the heart and they're headed out to the body, almost all of them carry oxygenated blood. But there's an exception. The one exception to that is the pulmonary artery. Because where is that carrying blood?
To the lungs.
Away from the heart to the lungs. So that blood is deoxygenated. Arteries are pretty elastic or sort of stretchable, and they are made of muscle.
Have you ever touched an artery?
because I know that.
Is it silence?
And the arteries that leave the heart, I don't remember the name of the biggest artery. Joe?
The aorta.
The aorta. So that's a very big artery. But as it sends blood to other places, it branches. And every time it branches, it gets what?
Smaller.
Smaller. It branches off and it's smaller and smaller, just like a tree. Each time it branches, it gets smaller and smaller. Until they get very, very small. When they get that small, then they turn into capillaries, which is the next type of blood vessel. Now on the inside, arteries are smooth. And, you know, you can feel arteries in your body.
What? You can't wear it for years.
Yep. Where else?
Yeah.
Yes. When you feel your pulse, whether it's in your wrist or I think it's easier if you go put two fingers on like the left side of your neck.
It's easier on my wrist.
If you bring them over towards like your throat, when you get like halfway there, you have this indentation here. If you push on that indentation,
It hurts.
don't push that hard. You could feel in that indentation.
I feel
You can feel your you can feel your pulse. Again, what's happening, what you're putting your fingers on is from your heart, branching off of your aorta, is a major artery that goes up through your neck. And every time that your heart beats, it's forcing blood into this artery. And so the artery each time expands a little bit. And when you feel your pulse, you're feeling the expansion of that artery every time that your heart beats. And that's what your pulse is. You can feel it in your neck, and you can feel it in your wrist is another good place. It depends. You got to get in the right spot, but after you find it, it's pretty easy to feel. But that's your pulse rate. When you're resting, it's about once a second or so. When you're exercising, it can go up to 200, over 200. If you're exercising pretty hard, it can go up that high. And again, it's increasing to help get enough oxygen to all of your body cells in order to allow them to do what they're doing. So if you're working hard and exercising, your heart's pumping faster because your muscles need more oxygen. So arteries carry this blood out of the heart towards all the parts of the body. But eventually they get very small and we start calling them capillaries. Capillaries are very, very thin. The wall of the capillary that makes it is just one single cell thick. And the capillaries are where materials can diffuse in and out. The arteries are too thick for oxygen or carbon dioxide or anything else really to diffuse through them. But when they get to these tiny little very thin capillaries, then they are thin enough that they're permeable to these things. And so oxygen, carbon dioxide, nutrients, they can diffuse in and out of the blood. So basically every cell in your body is surrounded by a capillary, this network of capillaries. They are so thin and so small that only one blood cell at a time can fit through. Okay? That's how small they are. They have to line up single file to get through the capillary. So here we have just a tiny little section of a capillary. And you see the red blood cells going through one at a time. Oxygen is diffusing out of the blood cells, and nutrients and carbon dioxide and waste diffuses in. So this is connected on this side to an artery, turns into a capillary, and then after the capillary, what do you think starts to happen? So the artery split up until it was very thin, then it's capillary. What happens at the end? At the end of the capillaries, they start merging together, and they start becoming wider and wider, and then they're veins. Then they lead back to heart. So arteries are connected and form capillaries, and they're connected and they form veins. So all of it's one continuous tube. It's not like arteries go and then there's like a dead end. There are no dead ends. They turn into capillaries and turn into veins.
Otherwise,
Shay?
capillaries look like cough drop pills.
Those are the blood cells.
Oh, the blood cells look like
All right, then we get the veins. So once this blood is gone through a capillary and it's headed back to the heart, it travels through veins. Veins bring blood to the heart. Some people remember because veins has the word in, so it's leading into the heart. And also, veins mostly carry deoxygenated blood because they're returning blood back to the heart. Most of it's deoxygenated, but there is an exception, the pulmonary vein. Pulmonary vein carries blood to the heart, but where was that coming from? No, pulmonary vein coming from the lungs, therefore it has oxygen. The inside of veins is also a little different than arteries. Arteries were nice and smooth on the inside. Veins are not. Veins have these little valves on them, these little one-way doors. And the purpose is to allow blood to go in a single direction and not reverse. So the blood can go through one way, but if it starts to come the other way, those little doors sort of close and they block the blood from coming back. Now they do, so those veins, those valves on the veins help prevent blood from going backwards. Because arteries don't need them. Because arteries are, the heart is forcing blood into them, forcing it to go through, so blood's not going to come backwards. But once it goes through all the capillaries and through the valves, the blood pressure is much lower, and so it's not getting pushed as hard back to the heart. So it has these valves so that it goes a little way, then it goes some more, but it doesn't flow backwards, and that's important. All right, so we have three types of blood vessels: arteries, capillaries, and veins. So if we look at some pictures here, this shows sort of major arteries and major veins in the body, and obviously they kind of mirror each other because wherever you have arteries carrying blood out, you need veins to return it back to the body again. There's another example. These show sort of the major arteries and veins. And again, this is your heart over here. Leaving your heart is the aorta, which loops down, goes through your torso, and then one down each leg. The ones up at the top, they split off and go down your arms, up through your neck, and that's the one you feel when you feel your pulse in your neck. The red are the arteries. Here you have just an animation showing the heart. Now again, if you remember, I talked about the aorta. It comes out, and then you see it loops down behind the heart. You could see these branches that lead to the arms and up to the head. You can also see on the outside of the heart, it has its own blood vessels that supply it with oxygen. We're going to talk about that in a minute. And finally, we have arteries. Again, they form capillaries, and then the capillaries start merging together to form veins. But they're all continuous. All right, this is an important diagram. It will be on your quiz. You're going to have to label this. And this is showing you a capillary network. And you're going to have to really just think about it to be able to label it. And it's really not as complicated as it may look. I know it has lots of arrows and stuff, but you'll be able to understand it. So in this diagram, first thing I need to tell you is blood is flowing from left to right in this diagram. So blood's going through and then out. All right, so let's start off with this. Number one, what is this blood vessel that's over here, Maggie?
Artery.
That's an artery. It was going away from the heart. That's an artery. This whole area in here is the capillary. And then over here, raise your hand and tell me what's number two. Austin?
Vein?
That's a vein. Because it's heading. Where is this blood headed? Back to the heart again.
The heart.
All right, now this capillary network, this very thin blood vessel, is surrounding these 5 different things here. What do you think they are? Those 5 things represent. Jared?
White blood cells.
Not quite white blood cells, no, but you're close. Yeah, they're basically body cells. They may be cells that are in your liver, or in your shoulder muscle, or in your brain, or in your small intestine. It doesn't really matter. But they're some sort of cell from your body, because every cell in your body is surrounded by this network of capillaries. How about number 4? What is these dots? What is that pointing to, Brandon? Yeah, what type? We talked about 2 types of blood cells. Yeah, those are red blood cells. Again, you'll notice as they go to the capillary, they basically just fit single file. That's how narrow it is. Number 5, surrounding these body cells, is this just like air or empty space?
No.
It's not.
Plasma?
Yeah, it's fluid. It's body fluid. It's not quite called plasma when it's here. It's called something else, even though they're basically the same stuff. Do you remember what we called body fluid?
Cytoplasm?
That's in a cell. We talked about a whole body system related to this. That what? Jared?
Something.
What'd you say?
The lymphatic system.
Lymphatic system. This is lymph, body fluid. It just sort of surrounds all the cells.
I don't know what that.
Now, to label the arrows here, these things that are moving,
What thing?
what you need to do is look at where is this arrow pointing from and where is it pointing to. So, let's look, for example, at number 6. Number 6 is this arrow. It's showing something moving
A body cell.
from this red blood cell into a body cell. Raise your hand if you could tell me what would be moving that way in a capillary. Joe?
A red blood cell that is diffusing with nutrients, with oxygen. What do you call it?
You're saying lots of words here. What's carried by red blood cells and given to body cells?
Oxygen.
Oxygen.
You could have just said that.
Now 7 is showing another. These aren't blood cells aren't just sort of free floating. What are they in?
Plasma.
They're in plasma. Okay, so let's look at the arrow 8. It's showing something moving from the plasma into the body cell. So what would that be? Going from plasma into the body cell. I need some new hands up here, not Joe, Maggie, and Jared. Brett?
Nutrients?
Yeah, those are nutrients that are dissolved in the plasma. Other things the cell needs besides oxygen. Good. Things like glucose or amino acids, whatever. Number 9 is a substance going from a body cell into the plasma. Jackson?
Waste?
Yeah, waste. Let's be a little bit more specific. What waste do you think it is? What's the main waste produced by cells?
CO2?
Yes. Carbon dioxide. What? So, this is what we call the capillary network, and you should know how to label all these various parts.
That was cool.
All right, we're skipping for today.
Oh, but I wanted to know.
All right, we got to talk about heart disease.
That's really bad. What's cardiovascular?
Heart disease. All right, so when we talk about when you talk about heart disease, it's probably not the best term. Because really what I'm talking about in these next few slides is cardiovascular disease. Because it's involving the heart or the vessels around it. So that's why I say that. So this is your heart. And so the heart is a what? What is it made out of? What type of tissue? Muscle tissue.
Yes.
Cardiac muscle.
Right.
So it's a muscle. It has to work constantly. If it doesn't work, then you die. So it needs to work constantly.
Stop breathing.
Therefore, it needs a constant supply of oxygen and nutrients, because like any other muscle, it takes energy for it to work. So it's important that the heart muscle itself has enough oxygen and other nutrients. So it has some blood vessels on the outside. So the heart pumps blood out and sends it back to the heart, to the outside, to supply the heart with blood. These arteries are very important because if they get blocked, if blood can't flow through these coronary arteries, the heart muscle itself can't get enough oxygen, it can't work, and therefore it stops working. And then the rest of your body can't get enough oxygen. So the coronary artery are the blood vessels that actually supply the heart with oxygen. Or 1 o'clock.
52.
I'm confused. So why would these blood vessels possibly be clogged? Christian? What's that?
Stop bleeding.
Well, you mean because like blood clots?
Yes.
That could clog them, I guess. What other reasons? Maggie? Shay?
Wow.
Yeah.
High cholesterol, good.
It's April, Mr. Duras.
I know,
Good job,
Get it
Maggie.
together.
Good job.
High cholesterol. What is
Good
cholesterol? Joe?
X.
It's a type of fatty substance. It's found in animal products, meat, cheese, dairy
I
products.
love cheese.
And cholesterol, it's also produced by your own body. So you do make your own cholesterol as well. But cholesterol can build up inside of the arteries and sort of clog them. This is called arterial sclerosis, the thickening of the arteries.
Is that good?
And often, no, it's not good.
Why would it be good?
Because
It's a question.
fatty substances like cholesterol, they start building up. They're called plaques. Kind of like the plaque that's on your teeth. You know, the dentist scrapes off. Similar idea. It's basically gunk that builds up in blood vessels. And you can see here's a normal artery. Here's one that has some buildup. And here's one that has a lot of buildup. So obviously if the artery looks like this, how much blood can get through?
Not a lot.
Not much. And the blood that gets through exerts a high pressure because it's going through this narrow opening. It can fill in completely and be 100% blocked, letting no blood get to that part of the body. So if these coronary arteries do get clogged with cholesterol and other substances, that can lead eventually to a heart attack. It also leads to high blood pressure, okay? Called hypertension. High blood pressure is when your blood is exerting a very high pressure on the arteries, possibly because of the buildup of this gunk. Also because of genetics. It could be because of stress or lack of exercise or diet. These are all things that can cause hypertension. And that, again, is something that's bad for you because it can damage your heart and other vessels. Jackson?
Is that what plaque psoriasis is? Or I saw a commercial for it.
I'm not sure. Joe?
My grandfather, he has, I think, one full block artery,
Yeah.
and he has another one halfway block. That's that.
Yeah.
He's like 2 blocks.
And tomorrow we'll talk about treatments and bypass and stents and angioplasty.
I thought catheters were when you had
Oh my god.
That is, we'll talk about that. The other thing, when you go, guys, listen, Bobby. When you go to the doctor, the nurse, they take your blood pressure. What do?
They squeeze your artery.
So what they're doing is they put the cuff on your upper arm, and then they listen in your elbow for your heart rate. And what they do is they pump up the cuff until they no longer hear your heart in your elbow. What that means is the pressure that they put in the cuff is equal to the pressure your blood's putting on your arteries, and they can't hear your heart rate anymore. And that tells you what the pressure in your arteries is. Then they slowly let it out while they listen, and when they hear your pulse come back, that's the second number that they were. Your blood pressure is 110 over 80 or like. That's for your pulse maybe, or it can be also measured your blood oxygen level. Maggie?
So, when it's like the severe,
Yeah.
what's called, like, but the blood trying to get out the one space goes over.
You mean here?
Yeah.
Yeah, the blood would just go through there, but it moves slowly
It
and
like
you
move and try to get out.
you kind of go through it, yeah. Yep.
My dad had high cholesterol, because my dad had it. But then he worked out really, really hard, and I was really skinny, so I didn't have it.
See, there you go.
Yeah, my grandma and my dad, and like, yeah, they have like really bad cholesterol, and my grandma, she's had like 2 heart attacks.
Yeah, some people are just naturally have it also. Some people even will exercise a lot, eat very healthily, but still have high cholesterol. There was a teacher who used to work here when I first started. Every day for lunch, as long as I knew him, he just had an apple and saltine crackers every day for lunch. He always ate very healthy, but he had very, very high cholesterol, and so did his parents. It was just a genetic thing.
So you can be born with it?
Yeah, you can just have it, and there's not a whole lot you can do about it.
When the doctor puts it in my arm, she said something going on, but it's not. It hurts.
Give me the next one. Is it food?
Yeah.
Wait, why can I have
It's like a lot of
Wow.
food.
It's a lot.
All that.
We don't like it.
It's bad?
No.
It's huge.
I know.
I can't eat all this.
Yes, you can.
I can't eat all
Well,
this.
then I have Melissa eat some.
No, this is, you guys even ate all that?
Yeah.
I'll eat a little.
Sophia, your stuff.
Give it to some, who's your second favorite teacher?
We should give some to Mr. Artery. I'll bring it to him.
What?
He's my science teacher.
Here, Sophie.
My foot hurts.
What is this? Blood?
Yeah.
Yeah, Sophia, it's your blood.
Wow. You guys didn't like this?
No.
It's a
Was it just you two?
weird
Yeah.
kind.
Yeah.
Wait, what'd you make?
Macaroni and cheese.
All right.
Quesadillas.
You can give this to your second favorite teacher.
Okay.
Hi, Sophia.
She doesn't even have you.
I know. Doesn't mean I can't be her first favorite teacher, even if I'm not her student. See you later.
Wait, where are you going?
Remember that thing you taught us about the scientific
Method?
yeah, was it
Yeah?
elephant something?
People really hate